Welcome back to the Dark Reading News Desk. I'm Terry Sweeney, contributing editor to Dark Reading, and joining me now is Ted Morocco of Approov. Ted, welcome back to the Dark Reading News Desk.
Terry, it's great to be back at RSA and great to be back here talking to you.
Well, here we are, and we sure appreciate you doing this. We're talking a little bit about some Approov research, which highlights this interesting figure that agentic AI bots are adapting attack code in real time with 99% human mimicry accuracy. That's
scary and correct. Yeah. So there's a number of studies that have been done recently. There's about 4 of them, different kind of levels of proficiency. But bots used to be stupid. They used to just be dumb scripts that were easily sort of identified, and vendors could pretty easily kind of block those things. But with the advent of LLMs, these bots now have brains.
Right, and PhDs apparently.
Yeah, exactly. They can solve all the math problems. They can beat the MIT math team, but they find it very easy to mimic human behavior. So they're not just like creative from testing or fuzzing API algorithms. They can also sort of mimic human behavior when it comes to behavioral signals that we've relied on in the past. So CAPTCHAs, even the motion of the mouse or the motion of the finger on the, we're concerned with the mobile devices, they can simulate the jitter of your hand in motion, and they can instrument these mobile apps with great proficiency, which is kind of scary for people who are trying to protect valuable data.
Sure. Well, I was going to ask you about that. Like, what does this mean for SOC professionals who are tasked with bot detection?
Well, it's a kind of a reinvention. The things that worked in the past aren't going to work in the future. I think that there is a whole slew of things that need to be done to try to, engineer these APIs to have a greater level of security than what's been done in the past. And that's kind of what we're working on. We study this. We work closely with partners and with customers to see what exactly is going on and to, invent the next level of defense to try to stop these kind of, persistent attacks.
Sure. Well, I mean, you've famously said that probability is no longer enough, which is maybe now an understatement with AI. But given what you cited with the fidelity that they can reproduce, say, thumb jitter or tap cadence, if the traditional methods that we've used to distinguish real users from LLM-generated ones, what is our new baseline for trust?
Well, you can come at this from 2 angles. So, that angle is really the negative security model. And the negative security model is, let's look for characteristics that would tend to indicate that this is a bot.
Okay.
So the other way to look at this thing is from the perspective of a positive security model. So, and that's really where we're coming from, is let's take a positive security model and let's try to test certain things that we know are okay. So let's look at the credentials, let's go beyond the credentials, let's look at the device that this thing is coming from. Is it been tampered with? Is it jailbroken? Is it rooted?
Sure.
Is it an emulator? These kind of things can all factor into a security policy that's geared towards that positive security model of who do we want to actually let in.
Okay. Talk to us a bit about how removing hard-coded credentials effectively starves autonomous bot's ability to reverse engineer its way into an API. How does that work?
Yeah. So the whole point of using these agents is you want to commit fraud at scale, and if you're going to do that, you need to have a playbook that works, and then you replay it over and over and over again. And the way that you attack, mobile is I think last year we stole a phrase that mobile is kind of a cesspool when it comes to a security perspective. The way, because a mobile app can be downloaded, it can be taken apart. And the traditional approach to security has been to put things like API keys into the mobile app and download it. And what we are advocating is that you take those secrets out of the mobile app and you store them in a safe place in the cloud where hackers don't have them. And if you take the API, this is how you starve the bots, the intelligent bots, is if you take away their food, which is the API keys and the credentials and things that they need to access the back end, you can effectively disable them because they don't have what they need to access to do these brute force types of attacks.
Okay. Connected to that is how deterministic defenses help avoid false positives. How does that work exactly?
Yeah, so let's start off with the false positives, and I'll come back to like the CAPTCHA example. So, you know, we were talking to a customer recently in an airline, and they were using CAPTCHAs on mobile devices to try to root out these kind of bad bots. And so the bots can now solve the CAPTCHAs, but they were also, you know, informed us that every second that it took for an actual human to work on a CAPTCHA cost them like $1 million. And it was usually taking about 4 seconds, you know, to kind of do these things. So they're losing millions of dollars because people just you know, move on. So,
okay.
So we want to have, so our approach is a deterministic model. So we're not going to force the user to solve a CAPTCHA or do anything like that. What we're going to do is we're going to go through a whole battery of tests to determine whether or not a person gets in or doesn't get into the API. And that is based on, you know, the integrity of the device, the integrity of the app, the integrity of the channel. Is there a possible man in the middle, you know, working in the channel? And if you pass all of these tests, then a token is issued from our attestation server, and that token is sent to the mobile device, but the mobile device never knows what is contained in the token. It's encrypted, and the mobile device then passes that token, binds it with the request to the API, and then the API will decrypt it and determine if it passed all those tests, it gets to go in. If it didn't, you know, it gets decoded, and that information gets, you know, presented to the business that's operating the mobile API in the analytics dashboard, so they can look at all the attacks that are going on, you know, and monitor it in real time. And
presumably that process can be done in 4 seconds or less.
It can be done in a few milliseconds. You know, it's actually, I mean, latency is a really important piece of our solution.
Sure.
And we are actually partnered with Cloudflare, and Cloudflare is one of the reasons why we have such low latency, is that with their smart routing, you know, and we have clients in China, so we need to do these attestations in China, for example. You need to get out of the Great Firewall of China, you need to get to an attestation server, you need to run this whole battery of tests, you need to get the token back through the Great Firewall and into a cell phone so a person can unlock a vehicle in Beijing or Shanghai or something like that. And we have clients that want to do that in less than 500 milliseconds.
Wow.
And we do it.
All right.
So the power is the software, and the power is also the network. You know, the network that we've deployed, very intelligent way of performing these tests so we can eliminate the latency. Because again, nobody wants to be sitting there trying to unlock their vehicle and waiting, you know, 5 seconds or something like that for a token to get back to the device.
Ted, take us out with some thoughts around the single most important architectural change that a CISO can make to ensure that their mobile APIs stay secure.
I guess that the single most important thing is that the way that we defended these mobile apps in the past is fundamentally broken. So the traditional approach to mobile app security has been code obfuscation. So take your secrets, you know, put them into the mobile app, and then try to obfuscate them so that you can't see them. AI has changed all that. So now we're living in a new world where, you know, it's very easy to de-obfuscate, you know, the software. So you need a different approach. You need this zero secrets architecture. You need to pull these keys out. And again, I think there's a tremendous power in short-lived tokens, so that if somebody, you know, gets into your API, they only get in for a few minutes. They can't perpetrate, you know, widespread kind of fraud if you have a short-lived token bound to every API request. So.
Right. Well, Ted, I so appreciate the update around mobile security, especially in this AI world we're now living in. Thanks so much for joining us on News Desk today.
Thank you very much. It's a pleasure being here.
We've been talking with Ted Morocco of Approov. This has been Terry Sweeney for the Dark Reading News Desk. Thanks for joining us for this segment. We'll see you next time.